Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 1 of lesson number 8, motion. Now, like the last class we discussed on the lesson diversity in living organism. Now that was a completely different lesson which comes under biology, right? And motion is something that we study under physics. So here you will have many different terms which will be included, like you will have distance, time, speed, magnitude, then you will have uniform motion, velocity. Now these are some basic terms that you might have studied earlier as well, but over here when we discuss that in this lesson you will be like studying more about it. There will be few examples which we are going to discuss in detail and many more things. Okay, so see, we are going to learn over here in the lesson, like how can you describe the motion of an object along a straight line and express such motion through simple equations and graph. What are we going to learn here? To describe the motion of object along a straight line and express such motion through simple equations and graph. And we will be also discussing different ways of describing circular motion. So we are discussing on we will be discussing on the motion of object along a straight line, and we will be discussing in detail about the ways of describing circular motion as well. So this lesson, like you can, many of you might find it very much easier if your basic concepts are clear, and if not, don't worry, we are like here to discuss on it, where we will be like, as this is part 1, we are going to do the basic introduction to the lesson, and just like you can say, through this part 1 I am like making you meet your friend, my friend, one of my friend, which is going to be your friend as well. Motion is my friend. You're going to know some of the characteristics of motion. You'll know more about motion, and when you meet motion next time, you'll feel like that it's your friend as well. Okay, we'll apply the same theory and we will study it. Okay. So, when it comes to understanding motion, we have two different terms first to know. One is reference point and the other one is reference frame. What did I stated? First is reference point and the other one is reference frame. Okay. So, over here, to describe the position of an object, we need a reference point or an origin. What do we need? If I have to describe position of an object, I need a reference point, which I can also call it as origin. Okay, so an object may seem to be moving to one observer and stationary to the other. Like for me, one object can be stationary, but for the other person, that same object can be moving, right? So we need to have a reference point, and we also call this reference point as origin. Now if I give you an example for this, let's say a passenger inside a bus sees the other passenger to be at rest. Okay, like the passenger inside the bus sees the other passengers to be at rest, whereas an observer outside the bus sees the passengers to be in motion, right? For us, we are sitting inside the bus, we are at rest. But for the others who are observing us from outside, for them, we are moving, right? So in order to make this observation easy, a convention or a common reference point or a frame is needed. So all objects must be in the same reference frame. What I concluded at the end, all objects must be in the same reference frame. And I told you about reference point is like if I have to describe position of an object, we need a reference point or origin. And you can explain this with example that an object may seem to be moving to one observer and stationary to the another. Now this is something very basic. You should be knowing this as well. So I want you all to write a note on reference point and reference frame, whatever we discussed, along with the same example that we just discussed now for like the observer outside the bus and the one who was like inside the bus at rest. I hope everyone is writing this. I hope everyone is writing it. After this, when it comes to motion, we have other things that you should know, that is what is distance and what is displacement. Okay, so you can say, like, if you have to define distance is something like magnitude of the length covered by a moving object. What did I say? Magnitude of the length covered by a moving object is called distance, and distance has no direction. So what is distance? Magnitude of length covered by a moving object is called distance, and it has no direction. Okay, and what is displacement then? Displacement is the shortest distance between 2 points or distance between the starting and the final position with respect to time. Suppose you are like going for a running competition. Okay, there's a start point and there's a final point, right, where you have to reach and you have some limited time period. So when you move from start point to the final point, that is what displacement is. Okay, so displacement is going to have magnitude and has direction as well. Now for distance, I said distance has no direction, but displacement has magnitude as well as direction. And always remember that displacement can be zero but distance cannot. Okay, what I said, I'm repeating it again. Displacement can be zero but distance cannot. So what is distance? Magnitude of the length covered by a moving object is called distance, and it has no direction. I'm repeating the definition of distance again. The magnitude of the length covered by a moving object is called distance, and it has no direction. When it comes to displacement, displacement is the shortest distance between 2 points, or the distance between the starting and the final position with respect to time. And always remember, displacement has magnitude and has direction as well. And displacement can be zero, but distance cannot. Okay, so I want you all to write this thing in your book. I hope everyone is writing about distance and displacement. You have to write that as well, that distance can be displacement can be zero but distance cannot be. Okay. After distance and displacement, the next thing that we will be discussing on is related to motion itself, right? Because once you know the distance and displacement, knowing about magnitude becomes important. Okay, so now what is magnitude? Magnitude is the size or extent of a physical quantity. What is magnitude? It is the size or extent of a physical quantity. And in physics, we have two quantities. One we have a scalar quantity and the other one is vector quantity. Which are the two quantities in physics that we have? Scalar quantity and vector quantities. And always remember that scalar quantities are only expressed as magnitude. What I said, scalar quantities are only expressed as magnitude, and the example includes like time, distance, mass, temperature, area, volume. These are some scalar quantities. And what is the difference between scalar quantities and vector quantities? Scalar quantities, they are expressed only in magnitude. Vector quantities are expressed in magnitude as well as in direction. Okay. Now example of scalar quantities include time, distance, mass, temperature and all, right? Whereas vector quantities include velocity, displacement, weight, momentum, force, acceleration. These are some of the vector quantities that we have. So I want you to write about magnitude and about the scalar quantity and the vector quantity in your book. I hope everyone is writing about magnitude and about scalar and vector quantity both. After magnitude, we have to discuss on time and speed, like what exactly time and speed is. Now, time and speed are the two common words that we like mostly used. So how can you define time? Time is the duration of an event that is expressed in seconds. What is time? Duration of an event that is expressed in seconds, and most physical phenomena occur with respect to time. So time is again a scalar quantity. What is time? Time is a scalar quantity. So duration of an event that is expressed in seconds. Okay. And most physical phenomena occur with respect to time, and time is a scalar quantity. Okay. After that we need to write about speed. What is speed? Speed is the rate of change of distance. What is speed? It is the rate of change of distance. So if a body covers a certain distance in a certain amount of time, what I said, if a body is covering a certain distance in certain amount of time, its speed is given by speed is equal to distance upon time. What is speed? Speed will be equal to distance upon time. Okay. So average speed is distance of an object, distance covered by an object within a period of time. Okay. So for speed, the formula is speed is equal to distance upon time, and for average speed, the formula is total distance traveled upon total time taken. What is the formula for calculating the average speed? Total distance traveled upon total time taken. This is the formula that we have. Okay. Now once you write about speed and average speed, I'll give you a difference between average speed and instantaneous speed. Okay. Because in this lesson you have all of these things only to discuss. So I'll just give you the difference and then we'll study one more topic and then I'll end. I'll not proceed with much part over here. I hope everyone is writing about time and speed. After this, we have like, as I told you, we will be discussing the differentiation between average speed and instantaneous speed, right? So average speed, you can define it as total distance traveled divided by total time elapsed, and it is going to be constant. Okay, what I talked about was about the average speed. Average speed is defined as total distance traveled divided by total time elapsed. Okay, and it is going to be constant. Then instantaneous speed is defined as speed at a particular instant of time, and it is not going to be constant. Okay, so average speed is measured by calculating the speed for an entire journey, whereas instantaneous speed is measured by speedometer. So if I have to instantaneously calculate the speed, I need a speedometer. But if I have to calculate an average speed, I can calculate or measure it directly by calculating the speed for an entire journey. Okay, for average speed, if I have to give you an example, it can be a car traveling with a speed of 60 kilometer per hour. So the average speed of the car will be 60 kilometer an hour. Then for instantaneous speed, where we need a speedometer to measure it, we can give an example that a car traveling at a certain speed at an instance of time given by a speedometer. Okay, so I hope you have understood like a basic difference between average speed and instantaneous speed. I hope you all are writing it. See, we have like after we discuss an average speed and instantaneous speed, we have uniform and non-uniform motion. Okay, so we have it. Just remember that we will be discussing that in the next class, maybe, or I'll just discuss it right now. Just write the proper definition and example for average speed and instantaneous speed. Okay. Okay. Now you can write with respect to like uniform speed and non-uniform. You can say uniform motion and non-uniform motion. See, when an object covers equal distance and equal interval of time, what I stated, when an object covers equal distance and equal interval of time, it is uniform motion. Example, if I give you for uniform motion is the ceiling fan blade. Okay, then motion of earth around the sun. Okay, these are examples of uniform motion. When it comes to non-uniform motion, it includes like when an object covers unequal distance in equal interval of time, then we call it as non-uniform motion. I'm repeating it again. When an object covers equal distance in equal interval of time, that is uniform motion. And when an object covers unequal distance in equal interval of time, it is non-uniform motion. Now example of non-uniform motion can be bouncing ball, running horse, moving train. These are all examples of non-uniform motion. Okay. So now next that we are left with acceleration and velocity. But before that, I want each one of you to please write whatever we have like studied with respect to uniform and non-uniform motion, because velocity and acceleration we will be continuing in the next part. And I need to introduce the lesson to you as well, so I'll be doing that as well. Okay, so now I'm going to like introduce the lesson to y'all so that we can start with it in the next class. So see, we are going to start the lesson motion by describing what exactly motion is. Okay, so motion means movement, and you'll come to know different types of motions as well. We'll study that. So we are going to study the next is motion along a straight line. How exactly like motion occurs through a straight line, and we will be studying that through this activity 8.1, where we will be studying the observation, explanation and conclusion. Then again we have one activity as 8.2. Then after that we will be discussing on two types of motion. One is uniform motion and the other one is non-uniform motion. So we'll discuss about them in detail. Then after that we have activity 8.3, which we will be discussing on in detail again. Then we will discuss on measuring the rate of motion, which is again very important. Like how can we measure the rate of motion? We'll study that as well. Then we'll discuss on this activity 8, example 8.1, like how can we calculate the average speed of the object. Now today itself we discussed on average speed and instantaneous speed, right? So we'll discuss that. Then we'll discuss speed with direction in detail. Okay. So we'll discuss this. Then again we have activity 8.4, 8.5, then example 8.2, 8.3. Then we have rate of change of velocity to discuss in detail, acceleration to discuss. I told you we are left with acceleration and velocity, so we'll be discussing them in detail. Again we have activity 8.6, then we have example 8.4, like how to calculate the acceleration. Then we'll discuss on the graphical representation of motion, like what motion is and how can we graphically represent that. Then we'll discuss on distance time graph in detail with respect to velocity. Okay, then we have velocity time graph to discuss. Then we have activities. Then we'll discuss on equations of motion by graphical method, like how can we write the equation of motion, but that is going to be by graphical method, not by the normal method. We will be discussing it with graphical method. Then we'll discuss on equation for velocity time relation, which is again very important. Okay. Then we have equation for position time relation, equation for position velocity relation, example 8.5, 8.6, 8.7. Then we have uniform circular motion to discuss in detail, like what exactly it is. Then we'll discuss on this activity 8.9 in detail. Then we have the summary discussion on the whole lesson. So as you might have noticed one thing, that this lesson is like all about stuff related to acceleration, velocity, speed, right, and how to calculate them, because we have so many examples for it, solved examples for them, and even there are so many activities which we have, so we will be doing. And at the end we have this summary discussion that we will be doing, and then we have few exercise questions which we are again going to discuss on. So I'm going to show you the question exercise questions one by one, and I want each one of you to please go through them properly, because you will get an idea what exactly we are studying. I hope everyone is going through the question that I'm showing you on screen. So here you'll get like many example based question where you will be like you'll have to solve it. Okay. So this is how we will be ending up with the lesson motion. And I hope whatever basic things that we discussed today, every one of you are clear with it. So I'll be starting with the lesson in the next part, but make sure you're revising whatever basic terms that we discussed today. Okay. So I'll end this part over here and I'll be continuing with the rest of the part for the lesson motion in the next part. Thank you everyone.